Welcome to the inaugural ceremony of the short-term course on Essential Tools in Optimization. I'm Dr. Anupam Yadav, host of the inaugural session. I'm glad to welcome our chief guest of the ceremony, Professor Lalit Kumar Awasthi, Honorable Director Dr. B.R. Ambedkar, NIT Jalandhar. We have with us Dr. Geeta Pratap, Head of the Department of Mathematics, NIT Jalandhar, Professor Jaspal Singh, Senior Professor, Dr. R.R. Sinha, Faculty of Department of Mathematics, along with Dr. Deepika Rani and Dr. Om Prakash Verma, the coordinators of the program. To begin the proceedings of the ceremony, I request Dr. Geeta Pratap, HOD Mathematics, to welcome our chief guest by presenting a plant.
सर अच्छा लगता है बाद में बच्चे कमेंट करते हैं तो मास्क नहीं ऐसा कुछ नहीं मैंने देखा थैंक यू सर
I request Dr. Deepika to welcome Dr. Geeta Pratap by presenting a plant to her. Now I request Dr. Geeta Pratap, HOD Mathematics, to give her opening remarks. Ma'am, please.
Honorable Director, NIT Jalandhar, my colleagues and dear participants, it is my pleasure to welcome you all in the 5-day short-term course on essential tools in optimization. I am glad that our department is organizing such course. Optimization theory has a very important place in mathematical sciences because it addresses many real-life problems and their possible solution. I have been told that about 225 participants in this program have registered who will be benefited by this program. I am happy to learn that a number of good experts from top institute of India will be teaching you the various tools in optimization theory. I am sure these lectures will be very beneficial for your research and academic needs, especially for PhD students and young faculty. I congratulate you all for joining this program. I am sure there will be many takeaway for you in the next 5 days. I wish the organizer and the participant for the success of this event. I am thankful to the Institute and Honorable Director for providing us the necessary help to conduct this short-term course. I wish you all a good health and safety in this ongoing pandemic. Thank you.
Thank you, ma'am. We are fortunate to have our Honorable Director, Professor Lalit Kumar Awasthi, with us in this opening ceremony. Professor Awasthi is a renowned academician and administrator. His active involvement in academics has enriched the academic community in many ways. Professor Awasthi is the director of NIT Jalandhar from 2016. In this short span, under his vibrant leadership, NIT Jalandhar has achieved many significant milestones in academics and research, including NIRF rankings. Before joining this institute, Professor Awasthi has served as a founding director of the Atal Bihari Vajpayee Government Institute of Engineering and Technology from 2012 to 2016. He also served as a director of Mahatma Gandhi Government Engineering College, Shimla, Himachal Pradesh. Professor Awasthi is a founding faculty member of the Department of Computer Science and Engineering, NIT Hamirpur, where he is a professor in the department. Professor Awasthi has supervised 10 PhD theses and authored more than 100 research publications in international journals and conferences. His academic journey is an inspiration to all of us. Sir, we are truly honored with your presence in the inaugural ceremony. I request you to please address the participants.
Good morning. Thank you, Dr. Anupam. for such a elaborated introduction. I sincerely try to be on what you have said. I definitely want to do a lot for NIT Jalandhar, and I congratulate all faculty members, students, staff for their wholehearted support, and it is the sport which has led this NIT to rank 52 all India. I congratulate all of you. Professor Jaswal Ojla, Dr. Gita Pratap, the convener Anupam Yadav, Deepika Rani, and Om Prakash, Dr. Sina from Mathematics Department. My journey started here in this institute in 2016. The institute, I'll take 1 minute. This institute came in 1987. And as on date, we have 11 undergraduate courses with an intake of 1135. And we have around 16 MTech programs and MBA programs. And another intake of roughly 550. We normally enroll 120, 130 research scholars every year. So since I have joined, my priority was that we should be able to have or enrich our regular faculty. So with the help of all at Institute NITJ, we have recruited 110 faculty members. And now the institute is ranked 52 all India, but we definitely need to do a lot to be in the top 20 institutions in the country. We compete with the NITs, IITs, and we are somewhere around 11th or 12th in overall tally of NITs. But a lot has to be done by faculty, students, staff, alumnus, and everyone here to achieve the target of coming in top 20 or top 10 in the country. The topic optimization is a very, very good topic which has been taken by the organizers. And mathematics is a founding pillar of any engineering technology course. So, and in that, optimization has been since inception one of the main area where most of the research and development is concentrated. So if some person joins a PhD in any discipline and he talks to his supervisor, what is the problem, say maybe X problem. So the supervisor will definitely tell him that we would like to look for optimization of these parameters during the research. So it is a basis of all the research areas. There have been lot many developments and a lot of new algorithms have come, which is due to computerization and computer inputs. And I think the galaxy of experts which have been invited to deliver lectures, they will definitely be able to give sufficient contents to the participants so that they can have their pursuits in their research, in their development, and they can further their research. I definitely want that the mathematics department of NIT Jalandhar should now become a computerized, automated mathematical department. They should think of starting some optimization courses. They should start doing some computerization, data analytics. There are lot many areas where mathematics can contribute a lot. If I remember the early days of computer science in India, then I can remember a lot of mathematicians who contributed in establishment of good computer science engineering departments in IITs and NITs. So I definitely want that NIT Jalandhar faculty should come forward and they should look into some of the IITs, NITs. They have started the BTech courses or MTech courses in mathematical and computationals. So we can always look for starting such program at NIT Jalandhar. I congratulate the team who has taken initiative under the guidance of Professor Ojla and Dr. Geeta Pratap. I wish that every participant have something to take away from this course, and I will be happy if the participants they share their inputs on the social media for NIT Jalandhar, and we should get a true picture of feedback of organizing such course. Thank you. Jai Hind, Jai Bharat.
Thank you, sir.
Thank you, sir. On behalf of Department of Mathematics and my own behalf, I am thankful to the Honorable Director for his valuable time to join the inaugural ceremony and addressing the participants. I'm also thankful for the support from his office to organize this event. Thank you, sir, for joining us in the ceremony. I'm thankful to Dr. Geeta Pratap, HOD Mathematics, for encouraging and supporting us to plan this event. I'm also thankful to the coordinators of the program, Dr. Deepika Rani and Dr. Om Prakash Verma, for their untiring efforts. Thanks to the participants for joining the inaugural ceremony. And it concludes this session. We'll now move towards the first technical session. Our first lecture is on nature-inspired optimization algorithms. Dr. Jagdish Chand Bansal will deliver it. And I'll take this opportunity to introduce Dr. Jagdish Chand Bansal. Dr. Jagdish Chand Bansal is an associate professor at South Asian University, New Delhi, and visiting faculty at the Department of Mathematics and Computer Science, Liverpool Hope University, United Kingdom. Dr. Bansal has obtained his PhD in mathematics from IIT Roorkee. His primary area of research is swarm intelligence and nature-inspired optimization techniques. He has published more than 60 research papers in various international journals and conferences. He is the series editor of the book series Algorithms for Intelligent Systems and Studies in Automatic Data-Driven and Industrial Computing, published by Springer. He is the editor-in-chief of the International Journal of Swarm Intelligence, published by InterScience. He is also the associate editor of IEEE Access, published by IEEE, and Array Journal, published by Elsewhere. Sir, we are thankful for the acceptance to deliver the lecture in this short-term course. I request you to please start the lecture.
Thank you, Dr. Anupam, for giving me the opportunity to be here and to interact with such a large audience. I'm going to speak on nature-inspired optimization algorithm today. I was informed that there will be many lectures on different nature-inspired optimization algorithms, and therefore, being this first lecture, I decided to be a general lecture and which will introduce the nature-inspired optimization algorithms in general and possible applications and possible areas of research in this nature-inspired optimization algorithm also. So let me share my screen with you. So I hope my screen is visible. Anyone can just...
No,
Yes,
no, sir.
Yes, sir.
You are visible, but not your screen, sir.
Yeah, visible. It's visible. Please
I think
change the layout.
for those slides are not visible, please change your settings. I think since I have now, I think it is visible.
Yes, sir.
Okay. So let me start with the nature-inspired optimization algorithms in general, and I will also recently, after having this COVID-19 pandemic, I also tried the application of nature-inspired optimization algorithm for the prediction of nature-inspired optimization. For the prediction of COVID-19. So what I in this lecture, what I will plan, first of all, nature-inspired optimization algorithms. Now onwards, I will call it NIA or NIO, right? So NIA in general, And then, since I'm a student of swarm intelligence, so I will concentrate out of nature-inspired optimization algorithms. I will concentrate myself to only swarm intelligence-based algorithms, and then I will introduce a few of these swarm intelligence algorithms in Solve, and then I'll also share the few possible applications and applied areas where these swarm intelligence and other nature-inspired optimization algorithms has shown their success. I'll share those stories also, and possible areas of application also, possible areas of research also in this area. And then at last, I will share a few of my experience with COVID-19 spread prediction using swarm intelligence. This research is still going on, is not still finalized, but we got some preliminary results, which I will share with you. Okay, so as you understand that the algorithms can be broadly classified into two ways. One is the derived algorithms. I usually classify the algorithms in two parts: derived algorithms and the inspired algorithms. Derived algorithms means the mathematically derived algorithms. There is a mathematical background of few algorithms. There are algorithms, for example, the Newton-Raphson method or the simplex method. Suppose for linear programming problem, there is a simplex method, very, very simple. Everybody must have heard of that method. So simplex method or the Newton-Raphson method, just suppose. So all these methods, steps, formulae, everything is derived based on certain mathematical derivations. So I name those algorithms as the derived algorithms. However, there is another category of algorithms which have no mathematical background. Means the algorithmic steps and the equations which are used in these algorithms have no mathematical background. Means the equation is not derived using some mathematical derivations, but this equation or the steps are written based on some natural phenomena, based on some natural process. So that natural process inspired researchers to write that equation or to write those steps, and then an algorithm is developed which is called nature inspired algorithm. So all these algorithms, steps and the equations are not actually mathematically derived, but they are inspired from the nature. And let me tell you, however, since there is no mathematical background behind those equations, but after having this very efficient machines, computational devices, these nature-inspired algorithms are working very excellent for solving the real-world problems. The problems in which the traditional or the derived algorithms usually fails, because for derived algorithms there are certain conditions always associated. For example, if you want to apply a simplex method to solve a linear programming problem, then definitely your problem should be linear. If you want to apply the Newton-Raphson method for optimization purpose, then the method itself requires that your function should be quasi-convex. So sometimes we need continuity, sometimes we need linearity, sometimes we need convexity. So a lot of mathematical properties are required if you use derived methods. And there may be few industry-related problems, may be very large or may not satisfy these kind of mathematical properties. In those cases, actually those derived algorithms are not applicable. If you will apply those, the required conditions are not satisfied. So in those cases, nature-inspired algorithms provide a good tool, a very good alternative for the optimization algorithms. However, nature-inspired algorithms not only applies to all these kind of problems where deterministic algorithms fails or the derived algorithms fails, but these algorithms can also be applied to the problems which can be solved using the derived algorithms. Means if you have a linear programming problem, that can also be solved using nature-inspired. So in a way, it looks like that if you have a nature-inspired algorithms, or if you can learn the nature-inspired algorithms, you can solve all kind of optimization problems. But let me tell you categorically that the nature-inspired algorithms comes with a warning, and the warning is the results are stochastic, results are probabilistic. obtained by the nature-inspired algorithms. Means, what does it mean? That if you have the results obtained by nature-inspired algorithms for a particular problem, then you cannot guarantee, the results are not deterministic, then you cannot guarantee the correctness of the results. Means the nature-inspired algorithms are not 100% reliable every time, are not 100% reliable, while the deterministic algorithms or derived algorithms are actually mathematically derived algorithms and therefore reliable 100%. Means whatever the result they will tell will be the correct, and there will be the unique result also, while the results obtained using nature-inspired algorithms may not be unique. Means I'm solving the same problem using same algorithm and you are solving the same problem using same algorithm. We both may have different results. Results are probabilistic. Also, I cannot guarantee that this is the final result. Nobody can find better result than this. Means there is always a probability that a better result can be obtained. If it exists, it can be obtained, right? So nature-inspired algorithms, however, are applicable to a wider class of problems. A wider class of problems can be solved using nature-inspired algorithms, but an associated tag, associated drawback is that the algorithms are stochastic, are probabilistic, and therefore, however, nature-inspired algorithms can be utilized to both kind of algorithms, both kind of problems, where the deterministic algorithms can be utilized and where the nature-inspired algorithms can be applied. But it is suggested that do not use nature-inspired algorithms if a problem can be solved using derived algorithms, if a problem can be solved using deterministic algorithms, because deterministic algorithms gives you the correct results, gives you the deterministic results, gives you the 100% reliability of the results, while nature-inspired algorithms are not giving you the 100% reliability on the results. And therefore, the nature-inspired algorithms can be utilized, can be applied only to the problems if your deterministic algorithms fails. There are many industry-related problems. There are many real-world problems, day-to-day life problems, where we are actually not that much concerned about the exactness of the solution. For example, just imagine a situation that there is a situation for, suppose, Mukesh Ambani, the Reliance Group. So he has many ventures, many businesses, and he wants to suppose that, okay, I want to reduce my investment cost or my running cost by 10%. My running cost I want to reduce by 10%. And for that, my first impression that I should do some employees, I should fire some employees. And then actually he will say that, okay, which employee from which industry, so that my business will have minimum impact. So now he has to pick up few employees to remove from their business. So in that case, if a good employee is removed out of, suppose, lakhs of employees, if one good employee is removed or if one bad employee remains, there is not a big difference. And if he says that I want to reduce my running cost by 10%, and if it is 9.9% running cost is reduced after that, firing of the employees, or 9.8%, then also the Mukesh Ambani or the Reliance Group will be happy. So in these kind of cases where the exactness is not that actually required, that much exactness is not required, but we need the results in very quick manner. Quickly we want the results. So in those cases, nature-inspired algorithms are a good tool. But just imagine another kind of real-world problem. For example, you want to decide the path trajectory for the mission Mangal. For Mangal Yan, you want to decide the path trajectory, and there we can afford the time, but we cannot afford the error. In those cases, it is warned that nature-inspired algorithms are not applicable. If you want the 100% accuracy, if you want the 100% reliability for the solution of a problem, please don't go with the nature-inspired algorithms. Only the deterministic algorithms are the answer for those. But if you can afford with some kind of error or some kind of approximate solution, if you can bear with, then nature-inspired algorithms are actually a better tool. So initially, when around 60s, these nature-inspired algorithms were introduced, and the first time this genetic algorithm became very popular in 60s. At that time, we didn't have that much good kind of machines, good kind of computational devices, very good computers we didn't have at that time. And so initially, when this genetic algorithm and other evolutionary algorithms were introduced, people were not happy with these kind of algorithms, and these algorithms were not so popular also at that time, because only the toy kind of problems. There is a de Jong test suit. There are 4 functions, very simple, like sphere function, x1 square plus x2 square. Minimize this function in a certain region, in a rectangular region. Minimize this function, x1 square plus x2 square. So these kind of 4 functions were there. So those were called de Jong's test suit. So initially, the genetic algorithm were tested on these kind of problems, and people used to say that, okay, we can solve a much bigger kind of problems using deterministic algorithms. And these kind of algorithms are not that much reliable, and all other kind of criticism about these algorithms. So yes, those criticisms were very much valid at that time, but not valid at this time, because now we have very good machines, good computational devices, and therefore we can do million, billion kind of calculations in fraction of second, and therefore nature-inspired algorithms are becoming very popular, very efficient tool to solve the problems. And I hope you understand that particle swarm optimization, genetic algorithm, ant colony optimization, these are the let me tell you, there is a report, industry report, ICMR report of 2018, which says that the market share of particle swarm optimization algorithm and the ant colony optimization algorithm in the industry for the algorithms is around 80%. In the algorithms, in around 80%, and particularly in case of robotics and the drones. In case of drones and robots, these 2 algorithms are contributing a lot. So because of having these drones and robots, the application of these algorithms has.
Excuse me, sir.
Yes.
So slides are not moving, sir.
I'm not moving those slides. That's why they are not moving.
Okay, I thought the PPT is not working.
Okay.
So I see.
So let me move. Now I think it is moving. Is it okay?
Yes, sir. Yes, sir.
Okay. So don't worry, but just please let me know if there is any kind of problem, like slide is not visible, my voice is not audible, I'm not audible, or whatever kind of problem. Just please, anybody, one of the participant, unmute and tell me, because I made my screen full screen, so I cannot see you all. I can see only my screen right now. Okay, so let me just quickly start the importance of this subject at this stage currently. In current years, I took the word computational intelligence, which is actually a broader word in case of nature-inspired algorithms. I tell you what is this computational intelligence, but just for timing, let me tell you that in Scopus, I put the keyword computational intelligence, and then I searched the total number of publications, and I found this trend that you can see that around 92 or so, people realized the importance of these algorithms, and you can see the exponential growth after 2000. You can see this exponential growth. Even this curve is more steep than the number of cases of COVID here in India, right? So you can see the exponential growth of research in this area of publications. So the world has realized that in 2000 that this area of research is really important and is very much applicable. And here I just then the same keyword, same search, just I restricted the publications from India. In the same research, I restricted that search to India, and then I found that you can see here from around 2006 or 2007, sorry, 2008, I think 2008, around 2008 or 7, this exponential growth starts. In India, it starts in around, so actually in India, we are around 7 years behind than the average world trend. Also, we are publishing around 5.98% publications in this area of the world publications. Total publications of the world and the publications from India, those are only 5.98% in this area. And you can see that we are 17% of the world population. The population of India is 17% of the world population, and we are producing only around 6%. So you can see that we are still lacking 11%. Around 11% we are lacking in this area. So just with these two graphs, I want to tell you that there is a lot of scope of research and development and the paper publications and of course the applications of these kind of algorithms in the real for publication and for the research. So if any young researchers is planning to have the research career, no matter you are which kind of engineer, it's a computer science engineer, mechanical, electrical, or mathematics. I'm a mathematics student. So you know, any kind of, these are interdisciplinary courses, and you not much mathematics is required, not much engineering is required, just a good kind of for doing research in nature inspired algorithm. You need to be a good programmer and a good observer. I always say that a good observer can do a better research. So observe the natural phenomena, observe the nature, and just convert those natural phenomena to a computational algorithm, and you have a good algorithm. Okay, so now the nature inspired algorithm. So if you say that nature inspired algorithm, then the algorithms can be classified into 3 parts: swarm intelligence algorithms, evolutionary algorithms, and the artificial neural network based algorithms. So in the swarm intelligence based algorithms, the algorithms are inspired by the cooperation behavior of the individuals. In evolutionary algorithms, the algorithms are inspired by the competitive behavior of the individuals, while the artificial neural network based algorithms are inspired by the working of the human brain. So I know that if engineers and these artificial neural network are based algorithms are very popular these days. This deep learning, GAN, all these kind of techniques are very popular these days. So artificial neural network based algorithms I'm not going to discuss. I'll discuss evolutionary computation based algorithms and the swarm intelligence based algorithms. I will also explain few algorithms in the category of swarm intelligence based algorithms. Okay, so if I concentrate myself on swarm intelligence based algorithm, then let me tell you, when I say that it's a swarm intelligence, then in which area of research, in which area of study I'm working. So let me tell you, I'm working in the area of artificial intelligence. So the artificial intelligence means when the intelligence is created or emerged artificially because of some interaction of the machines, right? So that is artificial intelligence. And when this artificial intelligence is emerged through iterative computations in the machine or in the algorithm, for example, like Newton-Raphson method. So Newton-Raphson method is an iterative algorithm. So similarly, if these artificial intelligence algorithms are iterative, then these artificial intelligence algorithms are called the computational intelligence algorithm. And when these computational intelligence algorithms has a property, additional property, that the individuals which are solving or which are iteratively improving their values are cooperating with each other, are informing each other, means when the population of solutions informed each other, help each other and improve themselves, then this is a swarm intelligence. Let me give you the formal definition of swarm intelligence, and then I will also tell you about the examples, about the real world examples where the swarm intelligence emerges. So if any participant has any question in between, I'm open. They can ask, or they can just note down their questions for the end also. I can take the questions in between and at the end also. No worries, right? So before I give this formal definition of the swarm intelligence, let me tell you about this just 12-second video. So I request just look at this video carefully. Just see. You see this video, and yeah. So there is something special in this video. Let me just play it again. That particular part. Let me play it again. You can see that initially the birds started flying. This bird's flock started flying in different directions, and after some time all the birds started to fly in single direction. That's the swarm intelligence. Swarm intelligence means that intelligence emerged among the birds after few seconds. Birds understood that we should fly in this direction. So this is an intelligent behavior. And how they knew it, the rule is very simple, which these birds follow. Actually, if we can formulate these kind of rules of the nature, of course we cannot formulate the exhaustive rules of the complex nature. Nature is very complex, that the God's creation, and we cannot formulate the exhaustive rules for the nature. But whatever we can understand about the nature, some simplified rules we can form. Some rules we can form, and based on those some rules we can develop an algorithm. So all is algorithm development in this nature inspired algorithm is just the observation of the situation, just the observation of the natural phenomena. So actually the researchers observed this kind of birds behavior. The rule is very simple. What they observed, that the birds are informed with each other, means every bird is informing to its neighbor. If one bird is here, if one bird is here, another bird is here, and another bird is here, then this bird is informing to him, this bird is informing to him, and also this bird is informing to him. So this bird is in connection of these two birds. So whatever the information this bird has, it will be spread to this bird also via the middle word. So actually this is a communication system they use. So I hope you understand that in mathematical language or in computer science language, this kind of communication mechanism is known as the ring topology or ring communication, right? So they informed all the birds with each other by this medium. So this is a neighbor to learning via neighbors. So peer-to-peer learning. So the birds are informing each other, and ultimately if this bird has seen, if majority of the birds in this direction are flying, then other birds here in this direction which were flying in this direction, then they realized that okay, majority of birds are flying in this direction, so let's move in this direction. So ultimately all the birds started moving in this direction. That's the way how the birds fly together. You must have seen the locust swarm also. Just few days before there was a news. So locust swarm, there was a news that 60 by 40 kilometer size locust swarm was there in some country. I just forgot the name of that country. There just few days before, the locust swarm was noticed that it is around 60 by 40 kilometer. Just imagine that this first locust is not informing last, is not visible to last, but still they are in a group. And the rule is very simple, just follow the neighbor, just follow the neighbor, right? But simultaneously they also follow one another rule, and which is that what is my situation, what I want. They say that okay, follow the neighbor, but they also understand their own informations, right? Own learning also. If they see that there is a wall in front, and this particular locust or this particular bird is going to strike that with this ball, then other birds, if they can see this ball, they will not move in this direction. However, this bird is saying to other birds, but they will not move in this direction, they will move in this direction, and with the help of this bird will also start moving in this direction, because this bird may have not seen this ball, but other birds, since they have seen, and therefore they will change the direction. So in this way, actually every bird is active, every bird is active, every member of the swarm is active in deciding the direction, and they are finding the most optimal direction in this way. So it is said in swarm that in swarm intelligence, every member is active, every member is working for the benefit of the group, and that's why the ultimate output is an intelligent behavior, and this intelligent behavior is known as the swarm intelligence. So this Bonavue gave in 1999 this formal definition of the swarm intelligence. Let me tell you that there are few important words in this definition. The emergent, the first word is the emergent. So let me tell you that the swarm intelligence is not the inherent intelligence. It is not inherent intelligence, means when the birds were here on the tree, they were not aware that in which direction we need to move after few seconds. Whenever there is any problem or any danger, which direction we need to choose to fly. They started flying in different directions. They started flying in different directions, but after a few seconds of interaction, means after a few seconds of collective efforts, I tell you, collective efforts. So it's a collective efforts also, and intelligent behavior is emerged. So it's an emerged behavior. It is not inherent behavior, it is emerged behavior, and it's a collective behavior also, because the efforts were collective, and it is always among a group of agents. Swarm intelligence cannot be obtained among one or two individuals or three individuals. Actually, for having swarm intelligence, you need a sufficient large group. And I did some mathematical and experimental studies on this, that what should be the minimum size to have the swarm intelligence behavior, and I found it to be around 10. Actually, mathematically, it is found 12, and experimentally, it is found 10. Of course, when I did some mathematical studies, you understand that these algorithms cannot be verified mathematically completely, and therefore to study mathematically these algorithms, I did some assumptions. I took some assumptions, and therefore based on those assumptions, of course some limitations. I hope you understand that these algorithms are having random numbers. So to study that minimum swarm size, I removed that randomness, stochastic property of these algorithms, and then I did some mathematical derivations, and I found the swarm size should be 12. Of course, I did a wrong model, so slightly changed recommendation I obtained, which is 12, and experimentally I found that around 10. Right, so 10 members can have the swarm intelligence, and mathematically 12. So final recommendation from my side is that to have a good swarm, to have a swarm intelligence behavior, not necessarily good, to have a good, it should be quite large, 30, 40, 50, around 50, right? So usually the 50 swarm size is good, but to have the swarm intelligence behavior, at least the swarm intelligence behavior, you need the swarm size should be 10, minimum should be 10. If you will take swarm size less than 10, then it may be that your algorithm cannot work, your algorithm may not work. I found there are many research papers, many studies, or actually what happens, sometimes people solve a industry problem which is very large and which takes a lot of time. So what they do to save the time on the computational device, on the computer, they reduce the swarm size. Of course, if you reduce the swarm size, your computational time will be less, right? But they reduce the swarm size, and by this reduction continues even less than 10, and at that time whatever the results are reported are not actually due to swarm intelligence, they are due to the randomness. So if your swarm size is less than 10, your algorithm is not working, actually the randomness is working. Whatever the results are obtained due to randomness, not due to the swarm intelligence, remember. So to have the swarm intelligence behavior, you need a group of intelligent agents, group of agents, not intelligent. Intelligence emerges. right? So this is a swarm intelligence which emerges through collective efforts of the agents in a group, and the group size should be around 10 minimum. Okay, so actually I just want to this is a video which I took from YouTube. Actually in this video the ants behavior is shown, the swarm intelligence behavior among the ants is shown, how they carry a some object and how they offer their abilities. Look here, this ant understood that there is a requirement this side, so it offers its ability from this side, and they started helping, right? So this is the way how the agents understand their responsibilities in a group, and they work for the benefit of the entire group. So I gave you example that if one bird has not seen the wall, this doesn't mean that other birds will also started to move to strike that wall. Other birds will understand and will move in the other direction, and that bird will also move in the other direction. So similar kind of behavior can be implemented to the robots also. So here you can see that this is a plate. Just a second. This is a platform which is to be maintained, which is to be balanced, and the optimal locations of these robots on the platform is to be obtained so that this platform is balanced. So you can see here the robots are finding their optimal locations in itself. They are helping with each other. They are informing with each other. All are connected with each other. Solidarity. They cooperate with each other, and they are finding the optimal location so that the this platform is balanced. So this is a swarm intelligence. Very good example of swarm intelligence. It is not necessary for swarm intelligence. It is not necessary that all the members are connected with each other. There may be a ring kind of topology. Let me tell you the topology kind of things. For example, they may be connected like this. They may be connected like this. That these members are. This member is connected with this and this with this. Also, they may be connected with each other. Means fully connected structure. Also means fully connected structure means everyone is connected with everyone else, right? So this kind of structure can also be there, and this kind of structure can also be there. But let me tell you, for having a fast swarm intelligence algorithm, it is recommended that you use the ring kind of topology instead of the fully connected structure, less connected structure. But here you can see that it is a ring kind of topology where if this, just imagine that if this bird stop working, just imagine that if this bird stop working, then there may be a miscommunication with this bird and this bird, because at that time the communication gap will be quite large, right? So in that case, sometime more than the ring topology connections are required. For example, in case of drones, actually we require less than fully connected and more than the ring kind of structure, so that if one or two drones in the swarm of drones, if one or two drones crashes, the gap can be filled by other drones or by other connections. Okay, so let me share with you some few popular swarm intelligence based algorithms. Particle swarm optimization, I hope everybody of you have heard. And another algorithm is this ant colony optimization algorithm, artificial bee colony algorithm, and recently we proposed this spider monkey optimization algorithm. Let me tell you, let me explain myself that since I have put here only the 4 algorithms in the category of swarm intelligence, this doesn't mean that there are only 4 swarm intelligence based algorithm. There are thousands of these swarm intelligence based algorithms are there. But I just shared a few popular and well established algorithms. Spider monkey optimization algorithm is not in that category, is not that popular like ant colony optimization or particle swarm optimization or artificial bee colony. Since this is my algorithm, so I put it here. It is still getting, but it's still getting popularity throughout the world. People are working in this algorithm, but it is not that popular. So these 3 algorithms are actually contributing most of the research publications in the area of swarm intelligence. Let me tell you that initially I told you that in industry applications, particle swarm optimization and ant colony optimization algorithms are utilized 80%. 80% algorithms are these two only, and in remaining 20%, all other swarm intelligence based algorithms are there. So out of thousands of the algorithms, only 2 algorithms are leading. And there is a reason for this. This doesn't mean that these 2 are the best algorithms. There are many better algorithms than these 2 algorithms. But what happened actually, the first popular, efficient, successful algorithm was particle swarm optimization in case of continuous optimization problem. Let me tell you that it is not necessary that if an algorithm is working for one problem, the same algorithm will work for another problem also with the same efficiency. So actually, let me tell you that ant colony optimization algorithms are very good for discrete optimization problems, and particle swarm optimization is very good for the continuous optimization problem. Similarly, artificial bee colony algorithm is good for continuous. Spider monkey optimization also good for continuous optimization problem. So these 3 are good for continuous optimization problem, while ant colony optimization algorithm is very good for discrete optimization problem. What does it mean? That if you apply the ant colony optimization algorithm for the continuous optimization problem, you may not get better results than the PSO. And if you apply the PSO for discrete optimization problem, you may not get better results than ACO. So actually these algorithms are not are called meta-heuristic. Are called meta-heuristic means the heuristics which are applicable to a wider class of problems. So yes, can be are applicable to a wider class of problems, but this doesn't mean that wider doesn't mean that all. Wider means many kind of problems, many type of problems, many problems, whether it is of mechanical background, whether it is of computer science background, electrical engineering background, biotechnology background, they are applicable. But this doesn't mean that all the problems are solved with same efficiency. They can solve. Of course, PSO can solve a discrete optimization problem also, but not as efficiently as ant colony optimization algorithm can solve. Similarly, ant colony optimization algorithm can also solve a continuous optimization problem, but not as efficiently as PSO or artificial bee colony algorithm can solve. Okay. So evolutionary computation, another category. Just quickly, I tell you the broad definition of evolutionary computation. I'll concentrate myself on swarm intelligence based algorithm. I will concentrate more on swarm intelligence based algorithms. So in evolutionary computation or evolutionary algorithm, the major operators are reproduction. You can see here reproduction, mutation, recombination, natural selection, and these algorithms are actually based on the survival of the fittest principle. Survival of when it is called the survival of the fittest principle means the individuals in the society are not always cooperating. Whenever there is a question of survival, they are competing with each other, right? So evolutionary computation based algorithms are actually based on the Darwinism principle of competition, survival of the fittest, means compete with each other, compete with other, make yourself better than others so that you can survive, others cannot, right? If the resources are limited. While in the swarm intelligence based algorithm, the philosophy is entirely different. The individuals cooperate with each other. If the one is not strong as you are, so then you will help the other and will make him as strong as you are. So everybody will become equally strong in swarm intelligence based algorithm. While in evolutionary computation, the members who are weak will die out and the new members will generate. New members will take birth, which are either better or equal to the current strong members, right? So, and that's why it is called reproduction. New members reproduce. They mutate themselves to become better in the current world. For example, it is said, I'm not sure, but because even the WHO is not sure about this corona. So about corona, they said that this virus is mutating itself from location to location. it is said that in I don't know, I belong to Gwalior, so the doctors itself in the Gwalior says that the virus which is in Mumbai, Delhi, like big cities, or in other countries like UK or USA, is more strong than the virus which is in Gwalior or small cities. It is mutating based on the immunity of the object. It is mutating itself, right? Because it wants to live there. Right? So mutation, the virus is mutating. Similarly, the human beings are also mutating. You know, we used to go to office daily. We used to give the lectures physically, face to face, and we mutate ourselves. And now we are interacting through this online because of this virus. So if there is any problem with the survival, if there is any question of survival, we mutate ourselves. So we mutate, and now we are close to our houses, right? So that's the survival of the fittest, because the humans progress or human survival is always based on this Darwinism principle. So based on this kind of principles, an algorithm is developed, a category of algorithm is developed, which is the evolutionary algorithm or evolutionary computation. The popular algorithms in this category are genetic algorithms. I hope this genetic algorithms, you must have heard of this name. Similarly, genetic programming, evolutionary programming, evolutionary strategy. All these 4 algorithms are of similar kind. Same kind of operators are used in these four kind of algorithms. There is another, my favorite algorithm, which is differential evolution. Actually, if about differential evolution, I tell you that it is one of the most simple algorithm for implementation. It is one of the fastest algorithm in this nature-inspired algorithms. But remember, there is a statement, no free lunch, in this category, which is derived from this Bible, that nothing comes free. So if the speed of differential evolution, the simplicity of the implementation of differential evolution comes, then there is a problem with this. The accuracy for the exploration ability. Exploration ability is relatively less in differential evolution as compared to others. Means if there is a multiple optima in your problem, then differential evolution may not give as good as results as genetic algorithm can give, right? So however, but differential evolution is not directly inspired from any natural phenomena, but the operators which are used in genetic algorithms are applied to differential evolution, and that's why I put this in the category of nature-inspired algorithms or in the category of evolutionary computation. So this differential evolution is actually having the operators from the evolutionary computation as well as from the swarm intelligence based update equations. Actually, this algorithm has the few properties which are not which are against of the evolutionary computation. This algorithm has few properties which are not satisfying the evolutionary computation principles. For example, in differential evolution, mutation comes first and then the crossover. Mutation comes first, then the crossover. While in all the evolutionary computation based algorithms, crossover comes first and then the mutation, right? Also, in differential evolution, mutation is a differential based equation, which is usually in swarm intelligence based algorithm. In differential evolution, the mutation process is a differential based equation, and in PS, so in spider monkey optimization, in artificial bee colony algorithm, or other optimization or other swarm intelligence based algorithm, the update equation is also differential based update equation. So it has some similarity with the swarm intelligence based algorithm and some similarity with the evolutionary computation algorithm, and therefore actually there is no hard boundary for this algorithm that I should put it in the evolutionary computation or in the category of swarm intelligence based algorithm. So this algorithm, just I put in evolutionary computation, but it can be put in swarm intelligence based algorithm and somewhere in between also. A very recent addition in this category is this biogeography based optimization, which is introduced in 2008 by one US scientist, Dan Simon. This is also getting popularity. It also has the same operators like genetic algorithm, crossover, and mutation. Okay. So let me quickly tell you about the philosophy. I told you that initially that I'll discuss the basic ideas behind these nature-inspired algorithms, and details will be covered in subsequent lectures. If I talk about a spider monkey optimization algorithm, let me start with the spider monkey optimization algorithm. It is a new algorithm. Let me tell you, it is a new algorithm and a lot of scope of improvement in this algorithm, lot of scope of application of this algorithm to various real world problems as compared to other algorithms. When I say the particle swarm optimization, of course, it is much popular. PSO is much popular than the SMO, spider monkey optimization algorithm, but PSO for research purpose, for modification purpose, is almost exhausted. Means there is a very difficult, very rare opportunity that you can improve further. You can improve, you can introduce further the new modifications in PSO. Of course, you can improve, but very difficult. While the spider monkey optimization can be improved relatively, can be improved easily as compared to the PSO or as compared to the ABC. Because they are old algorithms, so people have already implemented so many ideas on those algorithms and have applied to various real world problems also. So if you are not satisfied with those results of those real world problems, using those algorithms, you can apply this algorithm also to those real world problems. So let me quickly tell you about this spider monkey optimization algorithm, how it works. It is based on the foraging behavior of monkeys, a special species of monkeys which live in the deep forest, and that species is called the spider monkeys. Spider monkeys, when these monkeys suspend with the tree branch with their tail like this, there's a tree branch and they suspend with their tail with the tree branch, they look like a spider. So they look like a spider, so their name is like a spider monkeys. A spider monkey. This is the photograph of the spider monkey. Just for here, I just put for the representative purpose, just any cartoon kind of monkey, I put it here just for the representation. So the algorithm is inspired by the foraging behavior of spider monkeys, which live in the society or which live in the colony of around 50 to 60 monkeys. 50 to 60 monkeys live together, and out of these 50 to 60, always there is a female leader. Female monkey becomes the leader of this group. So here, actually in swarm intelligence, what happens? There is no concept of leader. Means there is no central control. No central control. All the individuals are equal. I told you that peer-to-peer learning. So peers are peers. No teacher. No, all are students. All are learners. All are teachers. Right? No student or no teachers. All are learners. All are teachers. Everybody learns, everybody teaches, right? So nobody is leader. But here in the spider monkeys, there is a leader. So I changed, for the implementation purpose, I changed the concept of the leadership. It is not a designated leader. It is not a fixed leader. It doesn't come from the family. It doesn't come from the Gandhi surname, right? Anybody who who performs good will become the leader. In my concept of the algorithm, the leader means anybody who is the best solution will become the leader. So here you can see here I marked this monkey as a leader. It means this is the best solution at this moment. Means it has the best knowledge about the forest, where the location of the food is. So this is the leader right now. So this leadership position will keep on changing based on the performance, not based on the surname only. Right. So you can see here in the morning, the monkeys, let me just quickly explain the foraging behavior of these monkeys. The monkeys start foraging in the morning. They find a leader, of course, the best solution. And whenever they see a food source, here they see the food source. And when they see the food source, they start eating here. They start eating the food here. And after some time, there may be a situation. Remember, it is not always necessary that these monkeys find difficult the sufficient food in this area. Means if the monkeys will, if all the monkeys will remain for some more time in this particular area, the competition will start. Means the food is not sufficient for this group. They have eaten some food and the remaining food is not sufficient for this group, and the competition can start. And since this is a cooperative society, this is a cooperative colony, this is a family, and they don't want the competition, right? And therefore what they decide, the monkeys decide that they divide themselves into two smaller parts, this part and this part, two smaller groups, and these groups are called subgroups. So you may call this as swarm, and you may call this as the subswarm or subgroups, right? So here is the leader. Now these subswarms will again have the leaders, and anybody who is the best of this group will become the leader of this group. Anybody who is the best of this group will become the leader of this group. You can understand that whoever is the best initially will join one of the group, and one of the group of leader is also the best of the entire group, right? So here now, since there are two leaders, not one leader, so now a name changed. This is called the global leader, and this is called the local leader. This is called the local leader, and that is called the global leader. So local leader and global leader, and you can see that one of the local leader is also the global leader. So,
excuse me, sir, PPT is not visible.
PPT is not visible. Just a second.
PPT is visible, I guess.
Visible at our end.
Visible at your end, then
You can rejoin, perhaps there is an issue.
PPT is visible, sir.
visible. Okay. So I can continue, right?
Yes, you may continue, sir.
Yes, sir. Please, you can continue.
Okay.
मैम आप अपना वो चेंज कर लीजिएगा, डेस्कटॉप का जो डिफरेंट लोकेशन होती है ना, वहां से आप चेंज करिए लेआउट, उसका भी हो जाएगी।
हाँ, लेआउट उसमें बॉटम राइट 3 पॉइंट्स हैं, उसमें आप जाके चेंज लेआउट कर लीजिए।
हाँ, चेंज लेआउट से हो जाता है।
Okay. So what happens? The monkeys divide themselves into smaller groups whenever they find the scarcity of the food, and then they search in different directions. So you can understand the benefit of this division. This word is called the fission. They do the fission, means division into smaller groups. Fission occurs. Here the fission occurs whenever there is a competition for the food. The fission occurs. So in this way, actually, they are searching the different direction of the forest. So initially they were together, so they were searching a limited area of the forest. Now since they are in two groups, they can search a better area of the forest. Then they start food foraging in different direction. And further, if this group realize that, or this group realize that there is not sufficient food even for this smaller group, they keep on dividing themselves into further smaller groups, and this process continues. This fission process continues till evening. And after the evening, all the groups return to their habitat, or return to their tree, wherever they live, they return there. So this process is called, returning process is called the fusion. The smaller groups fuse themselves into a single group. So fission and then fusion. Initially, throughout the day, they were doing the fission, and in the evening, they were doing fusion, right? So fission and then fusion. Fission and then fusion. So in other words, I say that the SM was inspired by the fission fusion social structure, which is a very unique behavior of these spider monkeys. Now for the implementation purpose, what I did, whenever I say that whenever there is a scarcity of food, it means whenever algorithm stops working. If the algorithm stops working, I say that there is a scarcity of food. Dr. Anupam, I think I have a time till 12:30. Dr. Anupam, can you confirm me? I can continue till 12:30, I think. Can you hear me, Anupam? Okay. Till he stops me, I'll continue. Okay, until 12:30 I got the Okay, thank you. What I did when I say that there is a scarcity of food and let us divide into two smaller groups. So in the algorithm terms, how to convert this concept to an algorithm? Actually, if you are planning to write an algorithm, it is good to convert the natural concepts to a computational algorithm.
Bansal sir, sorry to interrupt you.
Yes.
You can conclude in next 10 to 15 minutes. And
Okay.
since slot is by 12:30, but you can take as much as you find it well.
No, means I want to continue 12:30 just to be sure. But if you do you want 12:15 to finish by 12:15 or means?
Sir, it's up to you. The slot is by 12:30. You can.
Okay. Then I will continue till 12:30, right?
Okay, sir. Thank you, sir. Thank you.
Thank you.
Sir,
Thank you.
exactly, you continue, sir. This is very interesting.
Okay. Thank you.
Thank you, sir.
Okay, so actually, suppose if you are planning to introduce a new swarm intelligence based algorithm, or you are planning to improve the existing swarm intelligence based algorithms, then you need to understand that how the natural phenomena to be converted to a computational algorithm, right? So I told you the leadership concept, right? In the leader, I don't know how that female leader is chosen for the spider monkeys, but how I have chosen, I told you that best solution of the population is the leader. Then how to decide that there is a scarcity of food? So I say that if the global leader is not improving, itself, means the global leader is not modified. If the global leader is not modified, then I say that there is a scarcity of food. Means the global leader, the best solution is not improving. It means there is a scarcity of food. So I defined the scarcity of food in terms of the global leader position or the leader's improvement, right? If the leader is not improved, if the fitness of the leader, objective function value has not become better of the best solution, it means the algorithm is not working. Algorithm is not working means algorithm has lost its energy, and therefore I say that there is a scarcity of food, means this strategy is not working. Actually, why the monkeys are dividing themselves into two smaller groups? Because they realize that this strategy will not work. If we all will remain in this particular area for searching of food, this strategy will not work. We will not have the sufficient food. Similarly, I say that this strategy will not work, means whatever the way algorithm right now is working to find the solution is not working. This strategy is not valid, and therefore let's change the strategy. And what the strategy? That divide the entire group into two smaller groups or two smaller subswarms, right? So I decide the scarcity of the food based on the improvement of the solution, right? If the G best, if the global leader is not improved, then I say that there is a fission. Means fission criteria, fission will start if the global leader is not improved, right? So fission will start if the global leader is not improved. Similarly, if this local leader is not improved, then the fission will not further start. Look, the fission will not further start. However, in the real world, it may be, right? I also tried in my algorithm when I was implementing this. I also tried that if the local leader is not improved, then let us divide this particular group into smaller parts. No. So with this strategy, I was not getting good results. But what I did, if the global leader, again, one of the local leader is the global leader also, remember. One of the local leaders is the global leader also. So again, if out of all these groups, if the global leader is again not improving, only then you make the further division or further fission, right? So the fission or fusion, again, this fusion process, how the fusion is defined, I'm coming to that. Fission and fusion all is decided by the global leader, still the global leader. While in the natural life of the monkeys, it may not be the case. Remember, in the natural life of the case, actually this group may have gone to some other direction, and this group may have gone to some other direction, and they may not have the communication also. However, they may have the communication if they are close to each other by just barking to each other. But what I took in my algorithm, that they can communicate. Still, these smaller groups can communicate with each other because everything is in my control as a algorithm programmer, right? So they can communicate with each other. So I say that the fission or fusion, whatever is the decision is to be taken by only the global leader. Only the global leader will take this decision, not the local leaders. But this global leader will keep on the eye on the local leader's position. Means how the global leader will take this decision based on the local leaders' values, right? Based on the local leaders, whether they are improving themselves or not, right? So the global leader will take the decision, but based on the local leaders' position. So local leaders are important there itself. So this process continues, and so fission means the global leader is not improving. Now the fusion, when the fusion should start? Evening. In the real life, the evening is the fusion time. Means when the sun sets, the monkeys return to their home. Means they'll make the fusion process. But how to decide this in the algorithm part, right? So in the algorithm part, I say that since the group is limited, I don't have the infinite number of monkeys that I can keep on make the fission process up to infinite number of times. So I say that up to the time when minimum number of monkeys reached to a single group. I told you initially what should be the minimum swarm size. You remember the 10. I mentioned 10 swarm size. So I said that if a particular group has minimum 10 monkeys, then it's a time of fusion. Because if I further divide after 10, if a single group has the 10 monkeys, and after that, if I will further divide, then there will be no swarm intelligence. I told you that I did some experiment with the swarm intelligence. Less than 10, no swarm intelligence. So there may not be any swarm intelligence behavior, and therefore I said that around 10. It may be 12 also, it may be 15 also, based on the algorithm, but around 10. If the minimum monkeys are 10 in the group, then it's a time of fusion. It's a time of fusion means it's a time of evening. So make the fusion means make all the groups as a single group. Make all the groups as a single group. So that's the all philosophy behind the spider monkey optimization algorithm. And let me tell you, if you want to know about this algorithm more, there is a dedicated website, smo.scrs.in. You may note down this smo. Actually, it is difficult to note down this. smo.scrs.in. scrs.in. This is the website of this. So you can download from there the codes in Python, C++, MATLAB. All the codes are available. Paper are available. Also, there is a video lecture I prepared for this. In three parts, I prepared around 30 minutes or 20 minutes. Videos I prepared for this in detail, how this algorithm works. The detailed of full details of this algorithm are, so those are also available. You just Google or on YouTube, you search the spider monkey optimization video lecture, you will find that, or I can share the link also later. So if you want to learn more about this algorithm, you can see those videos and can download the code from this website. Another algorithm is this particle swarm optimization, which was introduced in 1995 by two US scientists, James Kennedy and Russell Everhart. And let me tell you that since this was the first algorithm in 1995 when it was introduced, so it became very popular. If I say that spider monkey optimization algorithm is not popular as PSO, this doesn't mean that SMO is inferior than PSO. Actually, this is just a time. It takes time to become the popular algorithm throughout the world. Researchers are flooded with these swarm intelligence-based algorithms. So it takes time to become an algorithm to be popular. So PSO is inspired by the birds flocking. I already explained you about this, or the fish schooling. The same behavior. Fish or birds use the same strategy for swimming or for the flying, right? Another popular algorithm is this artificial bee colony algorithm. My favorite algorithm, let me tell you, in swarm intelligence, very, very good algorithm. Here, the algorithm is developed based on the foraging behavior of honeybees. How the honeybees find always the shortest path or the in minimum possible time they reach to the flower from the hive. This is the hive. Suppose if this is the hive, then from this hive to the flower, they always reach in the minimum possible time, right, at the shortest path. How they find this strategy, how they inform with each other. So actually what happens, all this information is due to dance. The honeybees do the dance. Different kind of dances they do. They do the three kind of dances: waggle dance, tremble dance, and waggle, tremble, and round dance. So round dance is performed when the flower is very near to the hive, means there is no information to be given about the direction. Waggle dance is the most important dance, which gives the other bees all the information of a particular flower by one bee. So if suppose one bee collects the nectar from this flower, it completes the it completes her stomach with the nectar from the flower, and it reaches to the hive, unloads the nectar to the particular comb of the hive, and then perform the dance. And this dance has a particular direction with the sun. This dance, she always perform the dance in a particular direction, making certain angle with the sun, so that this bee will informing other bees that the flower is in this particular direction. So they take the sun as a reference point for the direction. Another thing is they perform the dance with different intensity, the speed of the dance. So speed of the dance says that it is near. The duration of the dance says that it has enough nectar to go with. The tremble dance is performed when the bee has performed this dance earlier and it is now performing to some other part of the hive. So it is by this tremble dance she is informing to other bees that I have performed this dance earlier, so this information is an old information. Other bees may have gone to that particular flower, so there may be a competition. So you decide yourself, right? So other bees, based on all these informations, take the probabilistic decision, means they give the probability. If the one bee's waggle dance is very good, then they give the probability 0.9. Okay, there is a 90% chance that I will go to this particular flower. And if the dance is not that good, or the information is not that sufficient, or not that good, then the probability may be less, right? So accordingly, the bees decide the direction, the particular location of that particular flower. So bees always reaches to the flower which are always full of nectar and close to their vicinity. You can see that the hives are always near to the flowers. If you have a good garden or something, then there may be a hive nearby. My house has 3 hives, right? Actually, there is a big garden near to my house. So here in Delhi, I have a lot of beehives near. Okay, this video I took from YouTube, in which in which this dance is to be shown. You can see here this bee is performing this waggle dance, and with this waggle dance, it is giving all the informations. Whatever the information is required by the other bees is given by this. Okay.
Sir, PPT is not visible. Your face is coming in instead of PPT.
I think now PPT is visible. No.
No, sir. I guess you have to pin your PPT.
Because of that video, I think.
Sir, pin the PPTs. It will be visible.
Yes. I know. Just a second. Give me a moment. I think now it is visible. Okay.
Yes, sir.
No, sir.
Huh?
PPT is visible,
but it's in a smaller window on your side panel.
Just a second. Oh, that I'm just stop recording and doing it again, right? Just a second.
Sir, I think it is visible. From my side, it is visible. I think it is their problem. They have to pin the PPT.
Now I think it's
Sir, it
It
is
must be
visible to everyone. There might be some problem with the individual. You can
Okay.
proceed with your presentation.
Okay, thank you. So another algorithm is this ant colony optimization algorithm, which is inspired by the foraging behavior of ants. And you can see that ants always find the shortest path from the nest to the food source. So actually they also follow very simple rules. You know, these complex problems are solved using one very simple rules. I told you that how the 40-60 kilometer long or large size locust swarm can be made, and the rules are very simple. Just follow the neighbor. Similarly, the ants also always find the shortest path from the nest to the food source, and the rules are very simple. If we can understand those rules and can implement somehow those rules to a computational algorithm, definitely we can have a very good algorithm problem solving approaches, right? As such, people say that it's mathematically derived, but let me tell you, all the big discoveries are inspired from the nature. Of course, the mathematical validity should be there, and there are mathematically and experimental validity also of these algorithms, but not mathematical validity is not in 100% way. Means not the original algorithm can be verified mathematically. All these swarm intelligence based algorithms can be verified mathematically also. I have written few papers on that. On those, you can search those papers. Stability analysis and convergence analysis I did for these algorithms, but of course by taking in those case I took certain assumptions which are actually against of the original algorithm, and then I did that analysis, and that's why of course that analysis is not the analysis of the original algorithm. That's why I say that the original algorithms mathematical analysis is not possible, but experimental analysis is possible, and all these algorithms are experimentally validated and are very successful. Because the natural creatures are successful, they are still live. Means from millions of billions of years the ants are on the earth because of this this cooperative behavior. Okay, so what they do, let me just quickly tell you that ants, whenever they start food foraging from the ants, from the nest, they start here, and suppose they at this particular junction, this particular junction, they find that there are two ways. Which path is to be chosen? This path is to be chosen, or this path is to be chosen, or this path is to be chosen. And initially, any path randomly. So initially, the ants can choose this path. This may be the path, or this may be the path, or the longest path. Longest path means this particular path. This path is the longest path. Randomly, they are moving randomly. So there are many ants. So they start moving in different paths randomly. All possible paths they explore initially. During this movement, always they do one thing, that they lay some pheromone on the path. From wherever they are moving, they are laying some pheromone. A pheromone is kind of chemical they deposit, and this pheromone has a property that it has a smell, so that other ants can smell that particular pheromone. And for other ants, the rule is that follow the high concentration pheromone. The pheromone which has high concentration, means this path, if this path has less concentration, don't follow this path. And if this path has high concentration, intensity of the pheromone is high on a particular path, only then the path is to be followed, right? So this pheromone has another property, smell, and number two property, that it evaporates with time. I hope you understand that the smell deteriorates with time. So if the path is longer, the ants will take more time in reaching to the food source. If the path is shorter, the ants will reach early. So the evaporation on the longer paths will be higher, and the evaporation on the shorter path will be small, and therefore the concentration on a small path will be more as compared to the concentration of pheromone on the longer paths. And therefore when the new ants will start from here, they will find that this particular path has more concentration because the evaporation was less. And therefore new ants will keep on moving this path and will depositing the pheromone, and ultimately what will happen, the pheromone will remain only on this shorter path. Longer paths pheromone will disappear, and only the shorter path will remain. And in this way, the ants will always find the shortest path from the nest to the forced source. And this kind of particular algorithm, this kind of natural phenomena is really very helpful for deciding the one very challenging problem, that is the robotic path planning problem. Robotic path planning problem means how to decide the shortest path for a robot from one point to another point. You know, if I can see the particular location that I want to go there, then if I can see that particular location, of course I can say that this is the shortest path. But suppose from here, from my room, I cannot see the Jalandhar location, then I need to rely on the GPS. I really need to rely on the Google Maps, right? Because the GPS, Google Maps, is based on the satellite who is looking from the top, the Uparwala, right? So that is looking, because that can see the entire to both the points, so that is giving me the shortest path. But just imagine that if you want to decide the shortest path from one point to another point in case of drones, in case of robots, in a GPS denied environment. Just imagine, in a GPS denied environment, if you want to decide the robotic path planning problem, then you need to rely on this kind of algorithms, ant colony optimization algorithms. And let me tell you, for drones, this is a very challenging problem and very much required problem also. It is very much required that we solve this problem, because GPS is not available everywhere. It may not be available in Galwan Ghati, right? In Galwan Valley, it may not be available. And if suppose there is a war, then if we want to send some drones or some robots or something, means if it is UAV's war, then definitely we need a GPS denied environment in which the drones or robots can find the shortest path. So, you know, in that case, these kind of algorithms can help to find the shortest path. Okay. This algorithm is inspired by the migration principle of the species from one island to another island. How the species migrate from one island to another island. Okay, I'm actually not sure. Can I just please mute participants? Somebody has unmuted. Okay. So please keep muting. If you have no question, please keep yourself muted. Okay. So I'm just not explaining. Please keep yourself muted. It is creating disturbance. Participants.
Dr. Bansal, thank you for your lecture. If there are questions, please, one by one. We will not be able to take many questions. Just unmute your mic and you can directly ask from the expert. But for sure, we are going to take 2 or 3, not more than that, questions. Or if you are uncomfortable, you can just write in the chat box. I will read that question for you, and Dr. Bansal may be able to answer it.
Dr.
So
Bansal,
actually, can Anupam, can I take 2 more minutes? Actually, I am not finished.
Yeah, okay, sir. Okay. I actually there was, I think, some confusion. If you want more time, it's okay.
Just 2 more minutes and let me complete, right? And then we'll start.
Sure, sir. Sure.
So actually, this somebody told in the chat box also that just quickly I tell you about that COVID study. So that actually this is an upcoming area and the study is still not complete. And if that idea can help somebody to further study, it will be good. So let me just quickly share. I hope now my slides are visible. Okay. So actually swarm drones, I'm just skipping this. This is also my area from last 2 years. I'm developing the algorithms for the swarm drones. And we are really successful. We have flown in practical also. 14 drones we've flown together and very successful. 50 kilometers we flown together one side and returned 50 kilometers. 14 drones together and accomplished a task also. Okay, so these are some few success stories I'll discuss. Just quickly, I tell you about COVID-19 prediction using swarm intelligence-based algorithm. So let me tell you, all the infectious diseases, those who have mathematics background may understand that all the infectious diseases model can be modeled as the system of first order system of ordinary differential equations, right? All the infectious diseases model can be like this, first order system of ordinary differential equations. Let me tell you, it is not difficult to have the solution of this system of differential equations, but when this system becomes very large and has a lot of data, then sometime it may not be possible to find the solution using traditional or mathematical methods, available mathematical methods. Then we can have a swarm intelligence approach to solve those. So let me tell you about this COVID-19. There is a model, SIR model. I hope most of you have heard this name. Actually, even this name is in news. Those stupid news anchors also are pronunciating the SIR model. Why I say stupid? Because they are expert of everything. So they sometimes they named like SIR model also. SIR means susceptible, infected, and recovered. But actually, in case of this is a general model for the infectious diseases. But what happens in case of COVID, SIR model is not applicable. There is a version of this SIR model which is called SEIR model. Susceptible, exposed. Exposed means the people who are actually infected but not showing any symptoms. So you may be aware that in COVID case there are many asymptomatic cases. So exposed are those category, and of course infected means those are infected and have symptoms, and recovered means those are recovered, right? And there is another version of this which is called SEIRS model, means as for again susceptible, means if one is recovered then also can have the chance to again infect. But in case of actually COVID, this is not the case. There is a very less chance that if one is infected, then that can also infected again, right? So the good model for COVID-19 is SEIR model. So this SEIR model is actually a collection of 4 ordinary differential equations, first order system of ordinary differential equations. And what we did, we modeled the differential equations as an optimization problem, because you know that all these algorithms, swarm intelligence based algorithms, are actually the optimization algorithms. So what we did with this work is with my PhD student Anshul Gopal, who is about to complete his PhD. So what we did, we converted the solution of differential equation into an optimization problem. And this conversion, this modeling part was the major contribution of us. This was the major contribution, because problem solving approach is very simple. It is existing. PSO and ABC we used, of course SMO also we used. We don't have the results right now of those, but PSO and ABC we used. So there is no contribution in case of algorithms, but the contribution is in terms of the modeling, that the differential equation is modeled in terms of optimization problem. And this modeling is also a very unique kind of thing that we did this time. And this modeling is done. Earlier, this modeling was, actually this model was not here in the slides. Earlier, this modeling was done based on the, there are few papers earlier also, there are few published research in which the differential equations are modeled in terms of optimization problem via Fourier series. But we used some transfer functions, some other kind of transfer functions, right? So combination, convex combination of transfer functions. And after that, we solved, we started with linear ODE, simple, just one ODE, and we did some experiments, and we found that this one very simple test problem is of which we know the exact solution, and we found this results. And you can see here that the ABC is very almost correct, means almost correct result it is giving. Remember, this is not the numerical solution at a particular point. Remember, we are giving you the generalized solution. This is, you know, if you are going to find the numerical solution at particular point, it is okay. There are many methods, but here we are giving you the generalized solution like the analytical methods, right? So like analytical methods, we are giving you the generalized method using swarm intelligence, which is not using any kind of calculus techniques, no mathematics, no calculus is there, and it is just like a black box. You have a problem, you have a differential equation, put it into this, and you have a solution, right? No calculus is required. No study of this differential equation is also required. That what kind of this differential equation is it? Is a second order differential equation, homogeneous, non-homogeneous, with constant coefficient, with variable coefficient, whatever kind of differential equation it is, it can be solved, right? And we did some experiment, and you can see here that ABC is really performing very good in case of linear ODE. Non-linear ODE also ABC is giving very good results. So we did all experiments on all kind of ODEs, and then system of ODEs. This is the COVID-19 case, that if you model the problem, means COVID-19 prediction can be done using the 4 system of ODEs. So I have the results. Just these are the test problem results. Still, the results on COVID-19 model we are working, and still it is not finalized. So I am not written here. But I tell you that if you want to take any help, it is not published. My results are not published. Still, I want to share those who are really want to work in this area. I'm okay to share with my initial findings if they want to extend the work for this better prediction. Right, so we found that the method which we proposed, the formulation which we proposed, the model which we proposed as an optimization model is actually very good working for the system of ODEs also. So that's all, and no free lunch theorem. So keep yourself inspired. Always, there is always a chance of improvement. There is always a chance of new developments. Don't get disheartened. If you have started research in nature-inspired algorithm and you found already thousands of the nature-inspired algorithms are there, and you say that what I will do, actually there is always a possibility for the improvement. I always say that best computational intelligence algorithm is swarm intelligence, because I work in this area. But actually, frankly speaking, I found it to be very efficient. I worked in evolutionary algorithms. I worked in neural networks also. I study other optimization algorithms also. Of course, I'm a student of mathematics, so I teach optimization. I study optimization, traditional optimization also. And of course, I have studied this nature-inspired optimization also, and I found it to be very effective, very efficient for solving real-world problems. And I tell you that, please don't concentrate yourself. Don't restrict yourself, your research to the paper publication only. If you have really the research attitude, please try to solve the real world problems. Please try to solve some problems related to this pandemic. This may be the distribution of optimal location of the beds in a particular city. For example, here in Delhi, we are facing a lot of problem with this COVID-19. So optimal location, finding optimal location for the what is that called, isolation centers, or all those optimal assignment of the doctors to those optimal assignment of the patient to the hospitals. Any kind of problem you can form and can help the government, can help the real world, right? And nowadays, I hope you understand that the government is also very open to take the new ideas. The DST has already opened their funding for the new research in case of COVID-19. If you have any idea related to COVID-19, please contact the DST. They have a lot of funding for those. Thank you so much. I have few information. I think this series, you can go to my website for all those information. We'll utilize this time for the question answer session. So I'm open now for the questions if you have.
Thank you, sir. Why don't you take 30 seconds to just share the society you run and what you do? It will be beneficial for the participants.
So just quickly. Actually, Dr. Anupam is also the editorial member of this book series. I am also editing this book series. It is by Springer, Algorithms for Intelligent Systems. Here we publish the conference proceedings, authored book, edited book. So if you have any plan related to this subject area, any kind of intelligent system, no matter whether it is computer science, electrical or mechanical or biotechnology, even any kind of intelligent system, if you are planning, you can send me the proposal. You can see the website. Just search the Google, you will find the website, or I'll share my presentation so you can have the link also. Another is this journal. which I'm editing, International Journal of Swarm Intelligence. Here we publish all kind of nature-inspired algorithms, not only swarm intelligence, but the evolutionary algorithms also. This is a society of which I'm the general secretary. Dr. Anupam is the treasurer. He has all the money of the society. Soft Computing Research Society. You can Google about this society, scrs.in. Please become the member of this society, fill the online form. There is a fees also for this, but that is not mandatory. If you don't want to deposit the fee, it's okay. You can remain the member without depositing the fee also, but can fill the form online, and everything is online. So that we are actually organizing right now we are organizing this SCRS lecture series on soft computing. So you can join that lecture series also. This is the signature conference of the series of the society. This time, this is the 10th version of the conference, which is being organized in the IIT Indore in December. The papers submission is still open. So if you are interested to submit paper in this area, please do submit. Thank you so much. I have taken enough time, and I hope I have finished in time.
Thank you, sir. Thank you so much for your time. And I can read the comments in the chat box, and that shows the content and intensity of this talk. I'm afraid I won't be able to take any questions from the audience now, because we are already have scheduled our next lecture. So thank you, Dr. Jagdish, for joining us in this first lecture. And there must be many takeaways from the participants from this lecture. We'll keep inviting you in this kind of lectures to have more interaction with you. Thank you, Dr. J.C. Bansal. Thank you.
Thank you, Dr. Anupam, and thank you all the participants. Please, I'll share the slides. If you have any question, you can write to my email also. I'll try my best to reply on email also. Thank you so much. Thank you.
Dr. Deepika, if you are there, please carry on.
Yes. So thank you, Dr. Bansal, for such an informative, well-organized and explanatory lecture. So I'm sure not only me, but everyone else has enjoyed it. So we will start with the next session, and the speaker for the next section is Dr. Harish Garg, Assistant Professor at Thapar Institute of Engineering and Technology, Patiala. Dr. Garg received his PhD degree with specialization of reliability theory and soft computing techniques from IIT Roorkee. He has authored more than 235 papers in international journals of repute. Being so young, so by now he has authored more than 235 papers, and he has more than 7,500 citations. So if I will go on reading, the introduction is really long. So without further delaying this, so we'll be starting with the next lecture, and the speaker, Dr. Harish Garg. Today he will be talking about the particle swarm optimization, and I hope that every one of us will enjoy the talk. So Dr. Harish, please, are you there? Hello?
Hello.
Dr. Harish Garg?
Yeah,
Ji, sir.
hello.
So you can continue with the yes.
Yeah. Let me firstly share my PPT.
So you please continue with the session.
Yeah, sure. I
Yes.
just share my
Okay.
PPT.
Okay. I guess. Okay, fine.
Let me know my PPT is visible.
Yes, Dr. Harish, it is visible. Please go ahead.
Yes.
Okay. Just couple of minutes is there. Just wait for it. Okay. Thank you, my friend Dr. Anupam and Dr. Deepika, for inviting me to here to present. I just changed the talk from particle swarm optimization to the artificial bee colony algorithm. So I sorry to say, but I just forget to intimate you that I just changed my presentation from PSO to the ABC. So, as Dr. Bansal introduced the various feature about the ABC, PSO, and basically the swarm intelligence in their very excellent talk is there. I appreciate Dr. Bansal is there. So, in this presentation, I'm not explaining what is the ABC. Remember that I'm not explaining what is the ABC algorithm suggested. I'm just explaining how it works on that. For example, all of you know that if I say my function is x square plus 1 and so on, then you can easily maximize or minimize the function with the help of some calculus or differential equations is there. But my task is to explain such type of the function with the help of the ABC, how it works when you solve on a copy and pen is there. So myself, Dr. Garg, has introduced my friend, Dr. Deepika Rani. So if I'm working in the School of Mathematics, if you feel any doubt, you can ask me through my email or through my website is there. So what is the ABC? What is the ABC stands for the artificial bee colony. So how it originated that? As in the last lecture, it is originated from the honey bee swarm is there. That is introduced by the Dervis Karaboga in the technical report 2005. After that, they just write the presentation on the artificial bee colony algorithm, and they presented a one paper with the co-author with the Bastard in 2007 in the Journal of the Global Optimization. So this is the first paper they have introduced about the idea on ABC algorithms, and several kind of the numerical functions have solved and their results are presented. So what is the ABC algorithm? How the ABC algorithm works then? So basically, the ABC algorithm is divided into the three phases. One is the employed phase, second is the onlooker phase, and third one is the scout phase are there. So what is the difference between these phases are there, and how ABC will move to their optimal solution starting from their any feasible or infeasible solution. So what is the employed phase suggested? It basically generates the new solution, and once we generate the new solution, then it will calculate the fitness. What is the meaning of the fitness is that is the objective function. Okay, so the task you want to maximize or to want to minimize, that is called as the fitness is there. After calculating the fitness, we will move on the greedy selection. What is the greedy selection is? So if we have a solution X, if we want to calculate the new solution Y, and then we will check that which one is the best among X or Y is there. So if I assume Y is best as compared to the X, then we can replace the X with the Y. Otherwise, we can preserve the X remain. So this is a phase employed did on that. While on the second phase, that is an onlooker phase, what he did is that again they produce the new solution, but it depending upon the probabilities. So if I say there are the 5 sources are there, and there are the 5 sources, and corresponding to them there are the 5 different kinds of the probability. So say these are the probabilities, and you know that the probability sum will be 1. So based on these probabilities, they can define the new solution, they can generate the new solution. Based on the new solution, they can define the fitness, and then again apply on the greedy selection. The only difference between the onlooker phase and the employee B phase here all the solutions are generated as a new. While on the onlooker phase, not all the solutions are generated as a new. Only those solutions generated which are satisfied this probability condition is there. So once we completed the onlooker phase, then it moves on the scout phase is there. What is suggest that we will find the abundant solution. That means if I say what is the meaning of the abundant solution is, that is we just give a chance to improve the solution to the 2 times, 3 times, 4 times. If it is still not improved, then we will apply the scout phase. So that chance we call as the limit. Okay. So for example, in our teaching line, in our universities, we just give a chance to the student to clear this particular course. So we can give a chance first time, then if he or she doesn't clear, we will give the second chance in terms of the repeer or the re-evaluation is there. If we again not clear, then we again give a chance. Okay, so that chance is called as the how many chances we have given to improve the solution is termed as a limit in the ABC algorithm. If with a predefined limits, if he or she still not improve the solution, then we will replace it with a new one and replace them. So this is a main basic phases in the ABC algorithm. So this is a I just quickly rewrite their working rule is there. What is that? Initially we just define the employed phase. What is that? For the each source means that is a solution. We just update the variables. What is the meaning of the variable? So for example, if I say my function is like this one, say this is my function. So how many variables are there? There are the two variables, x1 and x2 are my variables. Okay, so we will select the variable in the ABC, which variable you want to update, and then we will select the partner. That is, if I want to update the x2, I want to update with someone. So that someone is I call as the partner. So once we call as the partner, that partner is denoted with the xp, that variable is denoted as a x, then we will find the new solution with this equation. X plus 5 is a random number, lies between -1 to 1. And after that, we will perform the greedy selection. After updating each phase, we will calculate the probability. After calculating the probability, we will check whether this probability satisfies this number or not. If it is not, we will check the trial count, apply the scout phase, and then process will be repeated until our desired goal satisfied. So how the ABC algorithms work on that? How this complete process work, I just explained with the help of the numerical example, so that you may able to understand how the physically the ABC algorithm work. Based on this presentation, you may able to, if you are try to understand this presentation deeply, then you may able to understand, then you can easily write the MATLAB code of these ABC algorithms or any one of them quite easily. Or in other side, I can say that you can replace this function fx with your own research problem objective function, replace this domain with your own, and then try to solve in the couple of slides. The same procedure, you will get their optimal solution. So how many parameters are there which we need to set up before solving the ABC algorithm? So I just choose the random size. I just consider the population size as a 10. It's a very small number I just consider because in the presentation I am unable to write here as 100 because it's impossible to solve 100 cross 100 matrix is there. I just run the program over the 20 times. So and if you are working on the research side, then at least of the 500 iterations are more than at least 500 is there, and population size is at least of the 100 is there. What is the dimension of the problem here? Look at how many variables are there, x1 and x2. That's why this is my 2. Limit is I just take it here as a 1, but in general it is called as the swarm size multiplied with the dimension. Okay, so here is a 10 and here is a dimension is 2, so you can set as a 20 also, but for the sake of simplicity I just explain here as a 1. Now since there are the 3 phases are there, so what is the employed bees, number of the onlooker bees, and the food sources are always be the half of the swarm size. So if I just consider as a 10, so that's why it is a 5. If I consider as a 100, then it will be considered as a 50. So it depending upon the swarm size is there. Okay, so let's start that. So what is our goal of the ABC algorithm? So we will always try to update these 4 parameters or 4 filling the blanks are there. What is the food sources? What is the objective function? This FIT is called as the fitness. This trial is called as the trial vector. So I just explain you with the help of this step-by-step equation wise how to fill this all these blanks are there. So let's start with the equation number 1. Since my domain is from x1 to x2 is less than 5, so firstly the food source and my number of the onlooker bees are 5, so I just design the 5 numbers randomly chosen in between the domain -5 to 5. So how you choose them? This is based on this L is called as the lower limit. This is -5. plus any random number lies between 0 and 1. Upper number is 5 and lower number is again 5. So I just choose this for the 5 food source, and based on this I just calculate these 5 values are. Next phase is to find the value of the fx. So what is my objective function? So what is my objective function is, I have considered this problem is maximization of fx is here. So that this first column is representing my x1, second column is my representing x2. If you have more than 2 variables, then you can define the third column also for the x3 by using again the same rule is there. Okay, so based on this x1 and x2, I just substitute here for the first column. I can get this value, that is 3.1472 square minus of so on. You will get this. Third is, since the problem is the maximization, so I just represent here as a maximizer. So why we call as the fitness is the minimization. So how to calculate the fitness? So I just calculate the fitness based on this rule. If my objective function value is greater than 0, then I have to define the fitness as 1 upon 1 plus x f. And if it is less than 0, then we can define like this way. So what is that? Since my f is maximization, so look at that, then it is the reciprocal of it, so it will be my minimization. So how I calculate this value? So based on this, since the first value is greater than 0, so I can substitute here is 1 upon 1 plus f. It will get here. Similarly, you can substitute here, you will get this value. So this is the way to find these 3 values are there. The last one is the trial. How to find these values are there. So in order to find the trial, since there is a first iteration, there is no previous value. So that's why I just set up the trial values as a 0. But what is the rule for finding the trial values? So I can assign here as a 1, 2, 3 or 0. So this is based on this rule is there. So if the solution couldn't improve, then we increase the counter by 1. Okay, if it is improved, we reset to the 0. So what is the meaning is that if I found the new solution instead of this, if I found the new solution and the corresponding value is say this one. Okay, now look at the compare these two values. Since this is the minimum and we want the minimum of this, so this is the improve. So I can reset to be a 0. Whatever the value is here, if I say this is 3, we can reset to the 0. But if I found this value as a 0.531, then since this new solution couldn't improve then we can increase the value whatever written here to be a +1. That's the meaning of this one. Now look at that. So what is the employed B phase start there? So look at that. I just start with the first phase, and then after that I just move on the 1 by 1. What is the first employed B phase? So this is my first phase. Okay, so since this is my x1, this is my x2, so I need the 2 things are there. One is the variable, and second is we need the partner. So out of these 2 variables, this is my x1, this is my x2. Firstly, I just want to know which variable I want to update, either x1 or x2. That's totally a random basis are there. So you can select any one of them. So I just randomly choose the variable as a first. It means I have to update this value. Okay, so it means I just want to calculate this value. So this number is remain the same, and I want to update this value based on this mechanism of the ABC. So I just want to here. So I want to compare this number with out of these remaining food sources are there. So I just want to select the partner. So select the random partner. So I just consider the random partner as my fourth one. Okay, so since this is my x1, so I just replace x1 with the x1, and based on this partner, this is my xp. P represent for my partner. This is my variable. I can define the new solution or new food location with the help of this equation. X is my this. Phi is any number lies between -1 to 1. Okay, if you are working on the MATLAB, you can write in the MATLAB as a R, A, and D. That will generate your phi randomly. This is my xp. So you can substitute this value here. So I just consider phi as a 0.71. and can substitute this value in here, it will get 2.4467. And since my domain, remember always what's my domain is x1 and x2 lies between -5 to +5. So it will lies in between them. So I can replace the first solution with a new one, that is this. So it means now my this updated food source is 2.4467 and so on. Now calculate the fx value. Now this is my updated x1. This is my updated x2. Substitute this value in the fx. You will get this. Once you get fx, calculate the fitness value by using this equation, because f is greater than 0. Okay, if f is less than 0, then you can define this fit function as this one. So since f is greater than 0, so I can substitute here. You will get this value. Now based on this, now you have to update it, these values, this and this. Now you have to check whether the trial will be updated or not. But before updating the trial, you have to substitute this value here. So what we do is we have to apply the greedy selection. So compare the previous value with this new value. Since the task is to preserve the minimum value, compare the previous value with the new value. So which one is minimum? Since the previous value is less than of the new value, it means this new solution does not improve the solution well. So it means we have to preserve the previous values. So I can copy this complete line up to here and then preserve here. So look at that, the value remains the same. And the trial value is updated as a 1 because there is no improvement. So look at that. Updation rule is again the solution, the trial counter increased by 1 if it does not improve it. So look at that. What is that? My initial count is 0. So I can increase by 1. So it will become as a 1. So this is the phase. This is the updation phase of the onlooker of the employed B phase for the food source 1. Similarly, I can start with the second one. So what is the rule is? So the second employed phase. So I can select this one. So always remember these 5 steps are there. Whenever you try to understand the algorithms ABC, first thing is you have to find the random variable you want to change. That is either the x1 or x2 of this second piece. Select the partner. You want to compare this one with either first, third, fourth, or fifth. You have to create the new food source. Once you create the new food source, calculate the fx corresponding to new food source, calculate the fitness value of the new food source. And after that, perform the greedy selection, that is compare the previous value of this with the new one. If it is improved, you can update it the new value, otherwise preserve the previous value. So let's start with again. So select the random variable you want to update. So out of x1 and x2, which one you want to update? I assume that it's x2. It means I want to update here. Then select the partner. I assume that the partner will be my third. So it means I want to update. This is my x. This is my xp. This is my partner position. That is the second position. So assume that phi is my 0.31. So again, calculate this value by using the previous formula here. That's the mechanism of the ABC algorithm. So x is my this one minus of this. Phi I just taken as a 0.31. X is there. XP is my 0.4688. This one. So say after calculation, you will get this value. Again, it lies between -5 to 5. So this phase will update it as, so I can preserve the first variable x1 and the second value is here. Now calculate the fx and the fitness value. So based on this x1 and x2, I can calculate the function value. Based on this fx, again, the fitness is calculated as 1 plus f. Now compare this fitness with the previous fitness value. And since fitness is corresponding to minimum, so preserve the minimum value. Which one is minimum is here among this. So this is minimum. So look at that. So this value is minimum than of the previous value. So I can delete this previous value and update the new value with this one. So look at that. Look at that. This is updated. The corresponding solution fx is updated. Fitness is updated. Okay. So what about the trial value? So since the solution is updated, so whatever the value is here, we can reset to the 0. So what is the fitness of the 2? That is the second. It's a vector. So its fitness of the trial is reset to the 0. I again make sure that if it is, say, assume that if it is 4, then again, since it is updated, so you can reset to the 0. Whatever the number is here, reset to the 0. What is the meaning of this one? Means that the solution 1 gives a 1 chance, but he doesn't improve it. If I assume that here the value is, say, assumed to be 2, what is the meaning of this? Indicates that the solution corresponding to food source 1 indicates that it gives us the 2 chance, but still does not improve their solution. So that's the meaning of this trial is there. Okay. So since the trial is 0, so this one is there. So this is the updation phase of the second one. Similarly, so again, remember this important rule is there. Update the solution, update the trial counter. If reset to 0, if it is improved. Otherwise, improve the counter by 1 if it couldn't improve the solution. So let's start with the third phase, please. So what is that? I just consider third phase. Again, the 3 phases are there. So select the random variable which you want to update. So I assume that random variable is my 2. So I just want to update this number. Which one is a partner? I assume the first partner. So I assume the partner is here. So update, calculate the new position in between them. And by taking this phi as a 0.51, I calculate this value as a 2.7604. And again, it lies between -5 to 5. Remember that if assume that this value is come to be, say, 5.7604, but it doesn't lies between -5 to 5. So since it is upper bound, so we can reset to the 5, that is upper bound. And if it is, on the other hand, if it is minus of this, and since it is on the lower side, so we can reset to the -5. So what is the solution is? So we can update the second position, that is this. We can update this one. So I can firstly use this. So I can update this position. I can update here the second position with this new one. Now calculate the fitness value fx based on this x1 and x2. You will get this. Again, it is a positive, so you can calculate the fitness values here. Now perform the greedy selection. Compare this fitness with this third food source position. And since we want again the minimum of the fitness value, so which one is minimum? You can easily see that this new value is minimum as compared to the previous value. So it means we can delete the previous value and update with this new value. So look at that. I have to update this value here, and since the value is updated, so the trial value is reset to be 0. Look at that. Similarly, you can move on the fourth food source. Okay, I can assume that I have to update the value as a first variable. Okay, and a random partner, I have assumed that it's my second. So I have to generate the numbers between 4.05 to the 4.13. I consider phi, since phi lies between -1 to 1. So I assume phi as a -0.21. So I calculated this value here. Based on this, the new x4 will be this. Remember that I have updated only the first variable. So the first variable is here. So delete this, update with the new one, while the remaining remains same. So fx is calculated based on this here, and based on fx, you have to find the fitness value. Now perform the greedy selection between the fx and the previous value of this fitness value. So what we'll do is, you can see that the previous value is better than of the new value. So it means there is no change in this previous value. So I have to preserve the previous value and delete this new value. So I have to preserve this value as such, And since there is no updation in the previous value, so update this value with the +1. So 0 + 1 is my 1. Similarly, for this last phase, simply you can, in the last phase, this is my last particle, and I just want to update the particle as a 1, and the random food source I taken as a partner is 4. Okay, so generate in between them, consider 5 is here, you will get this number. And greedy selection, you can compare this value with the 5th food source. Here you will see that the new source value is better than of the previous value. So we can delete the previous value and update it with the new value. Now since this is the updation, so reset this value to be a 0. So since I have considered the 5 food source, so all the phases are updated. So the implied B phase is completed. Okay, so in the second phase, what we do in the onlooker side. So what we do is in the onlooker phase, we firstly calculate the probability. So in this, again, we will update the each four sources. Remember that. What is there? I just copied this new updated position into the onlooker B phases. So this is my new updated position. Now calculate the probabilities. So how to calculate the probabilities? That is based on this fitness value. So there are several rules are there to calculate the probabilities. So I just representing here the value of this, which is initially defined by the author, that is a Caraboga in 2007 paper. So I used this one to explain this procedure. What is that? This is fitness. So this is a value. So sum, you can find their sum, and then sum divided by this. So this, after calculating this, you will get this probability. And you know that the sum of the probabilities is 1. So you can simply check that the sum will be a 1. Now, based on this probabilities, we will implement the onlooker phase. Remember that in the last one, in the employed B phase, we are not depending on the probability. We will check the first B, update it. We will move on the second base, we will update it. We will third, again update, fourth, fifth, sixth, and so on. We will update it. But in the onlooker B phase, we will update the new food source generated only if it is satisfies this probability. So based on this probability, we will implement the onlooker B phase. So what is the procedure for that? We will select the random number. Okay. So based on this random number, we will check that whether it satisfies random number less than of the probabilities. If it is satisfied, then we will enter the loop for creating the new solution. If it doesn't satisfy, we will never update the new solution. So how to update the solution? That is remain the same as we did in the employed B phase. Again, this phi lies between -1 to 1. XP is nothing but the partner. X is the changing variable state. So let's start with that. So let's start with the first base. This is the onlooker base phase. So this is my first base is there. Okay. So we will check whether this B will update the new solution or not. That will depend upon the random number. So generate the random number which lies between 0 and 1, because the probability is always lies between 0 and 1. So we will generate the random number between 0 and 1 and check whether this random number less than of the probability. Since this is for the first B, the probability corresponding to the first B is 2.2415. Since it's satisfied, so we will update it. Okay, so we will try to update this new solution and check whether the new solution generated will improve the previous one or not. So how to update the solution? That is based on the same rule is there. Select the random variable out of this first B, which one you want to update, select the partner, and then so on. So I assume that the updated variable be my x2, and the partner I assume as a third. Okay, and I assume phi as my -0.69. So based on this, you will calculate this new position as my 0.6571. Again, it lies in the domain. So now this position will be, since we are working on the second position, so the first one remains the same. The second one is here. Based on this, we will calculate again and then so on. And then apply again the greedy selection. So look at that, the previous value is my 0.303, new value is my 0.0472. So since the previous value is less than of the new value, so it means this new food source will never minimize the problem. So it means there is no updation. So I will preserve the previous phase as such. Okay, and since there is no updation, so we will increase the trial counter by 1. So that's why this is 2. Remember always, the trial counter is increases when there is no updation in the solution. Okay, so look at the second B phase. This is my second B. Okay, so generate the random number. I assume that random number is 0.15. Now this is a second B phase, so compare this with the probability 0.2092. Again, it's satisfied. So assume the variable changes as a 1. Once you generate the random variable, check the probability, then change the variable. Consider the partner, any one of the partners. So assume it's the fifth. That's the fifth is there. So up this is the random variable 1. So generate between this and this. I consider phi as a 0.72. You will get this. So look at that. This number lies outside of the domain. So we will preserve to be a 5 and calculate the value as this one and calculate their new value. So once you calculate here, compare the previous value fitness. Again, there is no, so its new value is less than of the previous value. So we will update it. So delete the previous value, update it with the previous one. And since there is updation, so reset the value to be a 0. Similarly, for the third one, you can see that the third one, this lies outside the domain. So we can set to be a -5. And again, the value here is less than of this. So we will update it with the help of this. Again, there is updation. So there is no change updation. So delete, reset to the phase to trial value to be a 0. Look at the fourth B. The random number is generated as a say 0.35, but the probability is here. So since it is not be less than, so we will never go to the updation phase. It means so far there are the 3 updation, the fourth one is not updated. But remember that what is the onlooker? The number of the onlooker B's is my 5. Okay, so it means there is no need to update them because this doesn't satisfy this probability. Look for the fifth source. So since in the previous 3 cases this updation is there, but this is not been updated. So it means we have the 3 B's which are updated. So basically this is my 4th B's, which is moving on the onlooker phase, but this is the 5th food source. Okay, so that I'm just writing here as a 5th B's, but this is basically the 5th food source. So I just consider as a random number 0.13 and compared with the 5th probability and satisfied. So we will update it and compare the fitness value after the calculation. You will get this and compare the 5th value with this one. And since this value is less than of the previous value, so we will update it. So since it is updated, so the trial counter is set to be 0. So it means delete this value with the new value, delete this value with the new value, delete this value with the new value, and reset trial counter to be a 0. Now, since there is no food sources there, but remember my number of the onlooker B's are my 5, but here only the 4th piece is there. So it means still 1 B is pending to complete the loop of the onlooker B phase. So what will we do is we will move again to the first part. So that is my 5th base. That is again move on the first base, check again, generate a new random number, compare with the probability. If it is satisfied, move on it. If it doesn't satisfy, you can't move on that, check for the next one. But here I dissatisfied them, check the variables, second, again calculate the phase and compare the value with this one. Since the previous value is best as compared to the other new one, so there is no operation is there. So I have to preserve the previous value as such. Since there is no update, so I just update the trial counter with the previous value by 1. Look at that. This is not the one. What is the previous counter? Look at that. The previous counter is here. Okay, this is a previous counter. So you have to upgrade here as a 1. So 2 plus 1 as a 3. So that's why this is a 3 instead of the 1 plus 1. Because this is the previous iteration. And this is the updated equations are. Now, since all the 5 B's, the 5 is representing my number of the onlooker B's. So all are updated. So we can complete the onlooker B phase. So it means this is the updated position of my B's when you try to move on the maximize the fitness function or minimize their, or maximize the objective function or minimize their objective fitness values. So what is the basic difference would you have learned on the onlooker B's and the employed B's is there? What we have seen in the employed B's phase is all the food source values are used to generate a new solution. Okay, so whether it is better or not, how to check that whether it is better or not, we will apply the greedy selection is there. That is, we will compare the fitness value. If the fitness value is better in terms of minimize or maximize, if it is better, then we will update it. Otherwise, we will preserve the previous one. So remember here the word is all. So all the food source, whether the food source 1, whether the food source is the last, will update it there. While on the onlooker B phase, a food source may or may not generate a new solution. Look at that. If you see the first phase, the first B or the first food source will remain the same. It means it never generates a new food source. Similarly, the food source may or may not generate a new solution. So when it will generate the new food source, it will depending on the random solution, random number, and the associated probability is there. So if it is satisfied, the random number is less than of the probability, then only it will enter into the phase of their updation. Otherwise, no. So once we will update the employed B phase and the onlooker B phase, remember this is the most important phase is there. So once we will update the onlooker B phase, we will memorize the best solution so far. So I just copy the last this part. This is my best solution so far. So I have to find the best solution. How will, since my objective function is maximization, so objective function is here. So which one is maximized? Look at that. This is the maximum. So I have to preserve this. This is up to here. This is all the equation number 1. So at the end of the equation 1, what is my best solutions obtained so far is x1 is my -5, x2 is my 2.7604, best fx is my this. Okay, so once we will move on the equation number 2, we will again find the best value after completing the implied and the onlooker B phase, and we will compare this value with a new one. Assume that after the equation 2, say after equation 2, the fx I just obtained as a 48.314, and we will compare this fx with this one and again perform the greedy selection. So since this is the best one, so we will preserve this, remove this one. On the other hand, if my new value is my 148 point this, we will preserve this one and delete this new value, previous value. So similarly, after preserving the best answer, because problem is maximization, if my problem is minimization, objective function, then we will look at the minimum value. So minimum value is this. Okay, so then you will preserve this as a best food source and the corresponding fx is there. After ending the employed B phase and the onlooker B phase, we will move on the scout B phase. Scout phase. Always remember that scout phase may or may not encountered in every equation. Okay, it may be that after completing the employed or the onlooker B phase, we will move directly onto the employed B phase again without moving on the scout phase. So when the first question arises is when we enter into the scout B phase. So firstly, we will check that whether the Scout B phase implemented or not. For example, in this solution so far generated, whether the Scout B phase implemented or not, how to check that? So to answer this, we will check, we will take the decision based on the trial values that is calculated here and the value of the limit. Okay, remember that in the initial slide, we will set the limit as a 1. Okay, I just again recall that what is the limit is. For example, what is the meaning of this limit 3 is, it means the food source 1, this is my food source 1, food source 1 gives a 3 chance to improve the solution. Okay, but he never said, but he couldn't improve the solution from this. How many chances we have allocated here is 3. What is the meaning of this 0 is they have improved that. What is the meaning of this 1 is this food source 4 will give a 1 chance, but he still could not improve the solution. Okay, so that's why I just set up the limit as a 1, because I just want to compare this value as the limit 1. Okay, if I say limit as my say 10, so what is meaning is that I can give the maximum 10 chances to the each food source, and if it crosses the 10 chances, then we will only implement the Scout B phase. So that's why, for the sake of simplicity, we will define the limit as a 1. Otherwise, in general, it is depending on the dimension and the food source size is there. Here there are the 5 sizes, and what's the dimension is 2. So you can define the limit as a 10. So the decision is based on the trial value and the limit. So what is the decision is? This is there. Check first trial value with the limit. So limit I just set as a 1. If this condition satisfied, then only we can apply the Scout B phase. Remember, I hope you may be able to understand why we set as a 1. Why not as a 10? Because if we set as a 10, it means I have to increase the food source size or swarm size is there. That's why I only could improve limit size as a 10. If my swarm size as a 100, then it is quite possible to set as a limit as a 10. Okay, so but here my food source for the implementation side here, my food source is only 5. So that's why I just set up the limit as a 1. So since limit of 1 is 3, which is greater than of the set value 1, so it means the food source 1 couldn't improve the set desired value. So we can apply this Scout B phase. So what we will do in this Scout B phase, how to improve that? So in this, we will discard this solution. We will discard the solution and randomly generate a new solution. Because why we discard them? I again insist that because we give them enough chance to improve the food source 1, but they couldn't improve that. So we will improve this, discard this solution and generate the new solution over the domain. This is my domain. So how you generate them? That is a lower bound, this is a random number, upper bound 5, lower bound -5. So based on this, we will generate the new solution. So assume that the new solution generated as a 1. So we could replace this new solution, replace this previous value with a new solution here, calculate the fx value, this, fitness value, this. Since it is updated, so we will reset to be a 0. Okay, remember always, when you could update the solution, reset the trial counter to be a 0. Okay, if you couldn't improve the solution, increase the trial counter as a 1. Okay, now this is my new source is there. Remember always, you can't compare. Look at that. If you want to compare that the previous value is less than of this new value, so remember there is no greedy selection is there. You can't compromise that whether the new solution could improve the previous value or not. Okay, or you can say that you have to maximize this, or the new generated value is less than of the previous maximized value, so you can't update. There is no greedy selection in this Scout phase, because you have to improve. You give a tremendous time to the food source 1 to improve their solution, but they couldn't improve them by the 3 units. So there is no greedy selection, always remember that. So what is the at the end of the equation 1? What we do is look at that. Now this is the updated solution at the end of this equation 1. So this is the end of the equation 1. This is my 0, 0, and so on. Okay. So after the equation, the best source you have already found that is a 50. Okay. So again, now you can consider this as the initial count. Update, perform the equation number 2. That is start with the employed B phase again. Check this one. Select the source. Select the source variable. Select the partner. Okay. Select the phi. Select the solution. Perform the greedy selection and done so. And then again employed the onlooker B phase and so on and so on. So after performing the 5 equations, you will get this new B phase. Okay, and after the selection, you will see that the maximum value is here, and compare this maximum value with the previous one. So you will see the updated solution is here. Okay, so corresponding value is this one. And if you still, you can see that the previous value is 50 and best next value is 67. So when you terminate the solution, so all of you know that what is the termination criteria is when the difference, or you can say the slope gradient will be approximately 0, or you can say that f of x, the equation, what is that, the solution value at the I plus 1 equation and the solution value at the ith equation is less than of the epsilon. Epsilon is a very small number. It can be 10 raised power minus 6, minus 9, depending upon your desired goal. So since there is a very huge difference between the previous value and here, so you can update perform the 6th equation and so on. So after the 20th equation, you will get this new solution is there. Look at that. After 20th equation, your new solution will be here. Look at the maximum value is here, but I just put up here because it means in the equation number 19, you will get the best fx is my 88. So compare this 20th equation fitness value with the 19th, and since we want to maximize them, so we will discard this solution, preserve the previous value, and so on. So this is the quite, I'm not moving on the further side because this is the small example. So the task of this presentation is to just simply show you how the ABC algorithm work manually instead of this high benchmark problems are there. So you can try to tune your own problem with the help of simple manual calculation is there, so that you will be able to understand how the ABC algorithm works on our copy pen paper is there. What is the mechanism behind that? So I just quickly summarize what is the summary of this presentation is there. There are the 3 phases. Okay, remember that employed B phase is for the each food source. Okay, so there are the 3 steps are there. One is the updated the variables and the partner. Updation rule is you can use this equation always. Apply the greedy selection. Once you enter into the onlooker B phase, it is a bridge between the probabilities. Those satisfy this condition, only update the probabilities, only update the solution for those corresponding food sources. Once you completed the onlooker B phase, check whether it satisfied the limit counter. Okay, if it is satisfied, apply the scout B phase. If it is not, move directly to B here. Okay, so after implement the scout B phase, improve the equation count, and then move on. So you will terminate the procedure until your desired goal will satisfied, or your relative error or absolute error will be less than of your desired goal. So I hope you can enjoy this session and able to understand this talk. Thank you very much. So I just completed my presentation. So back to you, Dr. Deepika or Dr. Anupam. Hello. Hello. Are you audible?
Yes, yes.
Hello.
Yes, you are audible, doctor. You are audible.
But your slides are not presenting.
Throughout presentation.
Yes. Hello. No, we were able to see it.
Hello. During the presentation, my slides are visible or not?
Yeah, it
Yes.
was visible.
Yes.
Yes,
Okay,
sir,
I
it's
just
visible.
complete my presentation, so let me know.
All PPT was visible. It's really fine.
Dr. Garg, really, that was very much needed. And thank you very much. It is very good lecture, I should say. Thank you, sir.
Thank you. Thank you very much.
Thank you, Professor. What will be the recommended SWAM size for the given dimension? Is there?
Sorry, I can't hear. Can you please explain?
Can you have any recommendation for the SWAM size for the given dimension? If dimension is n number.
Oh, okay. Swarm size is basically if your problem has dimension alpha, then I can recommend it as a 20 times of the dimension. So for example, if my in this presentation I have considered a 2 dimension, so my swarm size will be 40. 20 times of their dimension is that could be the better than.
Okay, thank you, thank you. And is there any other parameter has to be tuned by for this and ABC algorithm? So other than
The only the parameter which is needed in the ABC algorithm is the limit.
So that will be recommended. Recommended size will be
Rest
SWAM into dimension. That will be the recommended limit value.
Yes, no, not swarm, or you can say the food source. That is the number of the onlooker base. Or if you say that swarm size divided by 2, half of the swarm size multiplied with the dimension is the recommended limit.
Okay, thank you, thank you. But in SWAM size, even 10, we are only selecting 50% of SWAM size alone, randomly initialized.
No, it's not a randomly, because if you taken as 100 as a swarm size, then 50 for the onlooker B phase and 50 for the employed B phase. 50 is not a random number. 50% we employed for the updation phase, 50 for the exploration, and 50 for the exploitation are there. That's why this is 50 for the onlooker and 50 for the employed B phase. Because remember in the talk, I mentioned that the onlooker B phase may or may not generate a new solution. It depending on the probability, dependent upon the fitness value, we computed the probability. So that's why 50% food source must be updated a new solution, or 50% will be updated based on their information we obtained so far.
But in the slide, in the employed phase, 50% of the SWAM has been allowed for the updation, and the same group alone can be carried out for the onlooker base. Based on the probability, we may update or not updated.
Yes.
But in the which indicates that the 50% of the SWAM size has been randomly initialized beginning.
You can say that it's a randomly pick up in the initially based on the swarm size.
Okay. Thank you.
Sir, we need your PPTs if you can provide. First thing.
Yes, of course. We'll get it and we'll send it to you.
And second thing is, sir, in ABC, what is the basically whether it is employed process or onlooker process, which one by which one a local minima is avoided? You can say. How do we get maxima, global maxima? in the problem there may be local minima or local maxima. So sometime optimization problem, they used to stick in local minima or maxima. So in ABC, what is the process basically, how it is getting toward maximum, global maxima or global minima?
Yes, yes. Because once you completed the onlooker as well as the employed B phase, so if it is struck to the local minima or maxima depending on the problem, then the limit, then the trial counter will automatically be increases to the limit size if it is struck to the local. So once if it is struck to the local, then the trial counter is increases to the limit value. Then in the scout B phase, you can eliminate the local solution and update it the new one. So that could be possible. That could be help for avoiding the local minima or maxima in the ABC algorithm.
I think it is a scout phase, which
Yeah, in the scout phase, there is a last phase, scout phase.
Thank you.
Because scout phase is only depending on the limit.
Thank you, sir. Thank you.
Welcome.
Excuse me, sir. Excuse me, sir.
Yes, please.
Can you provide MATLAB code for ABC? Can you share it?
Right now, I'm not providing here because due to the time constraint, I will upload on my YouTube channel. Is there? I already give that. If somebody wants again, this is the working of the ABC algorithm. If somebody wants to same procedure, you want to understand the working of the PSO algorithm, thus I already upload my lecture on this channel. Is there? You can browse on the YouTube, or already I can share it with you. I will provide the MATLAB code. I will try to implement.
Link. Hello? Can you share
Hello?
the YouTube link, sir? Hello? Am I audible?
Sure.
Please share your YouTube link.
Dr. Harish,
look at that.
Dr. Harish, why
Yes,
don't you
please.
just paste your YouTube channel link into the chat box so that the participants can easily access it?
Sure, I will post them.
Excuse me,
Let
sir.
me check. Is it chat is visible?
Yes, sir.
Posted that. Will let me know if it is.
Yes, sir, it is visible. Thank you, sir. Thank you
Yes.
so much. Excuse me, sir.
Yes, please.
Sir, suppose I'm working on a power system and working on smart grid, and how to create some equation from that model for this optimization analysis. How to do that? How to take that values?
Sorry, can you please repeat the question? Voice is disturbing.
Sir, like this, I'm working on smart microgrid concept.
Okay.
And that in that concept, how I have made a model how to create the equation of that models for the analysis purpose. How to take that values in a matrix form so that optimization technique can be applied. How to do that, sir?
Okay. The values which are representing in my slide is matrix form. These are nothing but the variables. Because if you are working on the electronic sides are there, firstly you have to create the objective function, and definitely the objective function is depending on some variables are there. Okay?
Yes, sir.
So and what's the domain of the variables are there? If you are working on the current size, for example, or charge is there. So if on the current you have to say that it's from 0.1 ampere to the 0.4 ampere. So these are the bounds. So based on this bound, you can define your matrices are there or variable is there.
Okay, sir. So how to decide which technique would be feasible for this particular model, this equation or this optimization technique would be resulting me to the best optimized solution?
Best optimized solution depending upon ABC, PSO, and all other algorithms. Are you talking about which swarm intelligence algorithm is better for the particular problem or only for the ABC?
So for particular problem, like for working model of grid, and then I have to apply optimization technique to see which optimization would lead me to a better solution, like whether applying this swarm intelligence or ant optimization colony or genetic or anything like that.
Okay, okay. No, no. First of all, remember the no free launch theorem in the swarm intelligence or optimization is there. So once you are solving the problem with the help of the ABC algorithm, for example, then you must have to solve the problem with the help of the PSO, SMO, and the other algorithms are there, and compare your performance results with the help of them and do some statistical analysis to prove that your result obtained by, say, ABC examples is better than the others are there. Always remember swarm intelligence, PS, for example, ABC is better for the one problem, or it may or may not be better for the second problem. So it depending upon the parameter tuning and the computation intelligence is are there. No one theorem, no one algorithm is better for all the problems are there.
Okay, sir. Thank you, sir.
Okay.
In the updation,
So,
one second. In the updation,
okay, there is another questions.
so can you change only one parameter?
Yes, please.
Yes, please. Go ahead.
No, like when you are updating the parameter, is it required only one parameter, or if we can allow more than one parameter to change update?
In the algorithm, ABC algorithm.
ABC algorithm, because in our
Yeah.
problem we updated
Yeah.
only one parameter. Is it required limited to only one parameter, or we can change more number? If the dimension is 10,
You can select a randomly number of the parameter which you want to update them. You can select two, more than two, one. It's depending upon you. It basically depending upon the if you want to update more, then the computational process will be small.
okay, thank you, thank you, thank you.
So thank you, Dr. Garg, for such a wonderful talk. After your talk, I could remember just one idiom, "Gagar mein sagar banna." In such a small time, you have presented so wonderfully, and it was so nice. So thank you for your cooperation. And after just one call, you were ready to give your talk. So I'm really grateful. So I thank you so much, Dr. Garg.
Oh, my pleasure.
Thank you. Okay. So, okay, dear participants, we are, let's call it a day for today. And tomorrow we'll be starting at 11 sharp with the same Google link. Hope to see you tomorrow. Stay safe, stay happy. Thank you.